Welcome back. In the second half of this section, we're going to talk about some other factoring techniques, and we're also going to look at factoring out things that have negative exponents or fractional exponents. First off, a factoring technique that may sometimes work for you if you have an even number of terms is factoring by grouping, which is kind of a modified way of doing common factoring. Instead of taking out a common factor from all of the terms, instead what we do is we split our terms in half. So we have our first half and we have our second half, and we'll take common factors out of both halves. And the goal here is for both of the two parts to have the same thing left over. So I'm going to get myself started here with this first one, beginning by first, of course, always asking myself, can I just take out any common factor from everybody? And of course, if you look at all of the terms, there's no factor that's in common to everybody. Also, it's good to ask ourselves if any other factoring technique applies here. This is not a difference of cubes, it's not a sum of cubes, it's not a difference of squares, it's not an x squared plus x plus constant kind of situation. So none of those techniques will work for us, but we notice we do have an even number of terms, so we'll try factoring by grouping. So from the first two terms, I can factor out 4 and I can factor out x squared. And when I do that from the first two terms, I'll have 3x and plus 2 left over. So now I want to look at the last two terms. I want to take out some kind of a common factor, and my goal is to have the same thing left behind. My goal is to have 3x plus 2 left behind. If I do, then factoring by grouping has worked, and that means it's great. I'm one step closer to being finished. And if I can't, then it means factoring by grouping won't work. Now, in this case, I certainly could get a 3x plus 2 left behind if I were to factor a -1 out of the last two terms. If I did that, I'd have 3x plus 2 left behind. And so now, the reason for why this means my factoring by grouping has worked, now instead of having 4 individual terms, we've got 2 big terms, and in each of those 2 big terms, you've got 3x plus 2 as a factor. So that means you could take 3x plus 2 out, leaving behind the 4x squared from the first term and the -1 from the second term. Of course, don't forget that we still need to ask ourselves if our factoring is finished or if there's any other work that needs to be done. And in this case, there certainly is 4x squared minus 1. You might have noticed it, and if you didn't, now you will. It is a perfect square minus a perfect square. 4x squared is 2x that's been squared, and 1 is 1 that's been squared. So 4x squared minus 1 should factor as 2x plus 1, 2x minus 1. So factoring by grouping is a thing that we can try when we have 4 terms. It doesn't always work, but there is one case in which it's guaranteed to work. And that's to help us factor these kinds of polynomials, ones that have x squared plus x plus constant, where the x squared term is not just x squared, but where it's got some kind of a coefficient on it. So we're going to do the same sort of finding two numbers business. We find two numbers, p and q, that multiply together to give us, in this case, the outer coefficients multiplied together. And they need to add up to whatever our x coefficient is. And once we find our two numbers, we're not immediately finished like we were before, but when we find our two numbers, that's allowing us to take our x term and split it into two different x terms. So that now, instead of having a polynomial that had 3 terms in it, we'll have a polynomial that has 4 terms in it. And of course, if you've got 4 terms, that means you can try factoring by grouping. Now, here I'm going to make a little promise, and that's for these polynomials, if you find your two numbers correctly and you've split up your middle term into those two numbers, then factoring by grouping is guaranteed to work. And of course, the opposite is also true. if you've tried splitting up the middle term into two terms and factoring by grouping is not working, then that means you found the wrong two numbers, and you need to go back and check to see whether the two numbers are correct or not. So let's do a couple of examples here, starting with 5x squared minus 18x minus 8. So when we're looking to try to factor this, we need to find numbers that multiply together to give us 5 times negative 8, or in other words, multiply together to give us negative 40. And they need to add up together to give us our coefficient of x, which is negative 18. So we go through our list of things that multiply out to give us negative 40, and I hit upon negative 20 and positive 2. And it's just good to double check that they do what we say that they should. So I check to see, do these two numbers add up to negative 18? And they do. Do they multiply to negative 40? And they do. So what that means now is I'm going to take my polynomial that I originally had, and I'm going to split the x term into a minus 20x and a plus 2x. And it doesn't matter what order you do them in, whether you do the minus 20 first or the 2 first, doesn't really make any difference. So I'll put it as the minus 20 first, and I'll do the 2 afterwards. But if I did it in the other order, I'd still get the same result, which is, since I found the two numbers correctly, then factoring by grouping is guaranteed to work. And so that means I should now, from the first two terms, take out a common factor. That would be a 5x, and that would leave me with x minus 4 left behind. And I should be able to find something that I can factor out of the last two terms that also leaves x minus 4 behind. And I can see that if I factor out a 2 out of the last two terms, that I do indeed have an x minus 4 left behind. So that means x minus 4 can be factored out of the two big terms that I've got, leaving behind 5x from the first term and 2 from the last. All right, let's do one more. We've got ourselves this minus 6x squared minus x plus 15. And so same sort of thing here. I'm going to start off by finding my two numbers. So these two numbers need to multiply together to give me negative 6 times 15, which is negative 90. And these two numbers need to add up together to give me negative 1. So if I were to take negative 10 and positive 9, and just to double check, those two numbers, they add up to negative 1. Just to double check again, they multiply together to give me negative 90. So since I found the right two numbers, then if I split up my x term into a minus 10x and a plus 9x, then factoring by grouping should work. So let's see if it does. From the first two terms, I could factor out a negative 2, and I could also factor out an x, and that would leave me with a 3x plus 5. And so, again, my goal is from the last two terms to have the same thing left behind. So from the last two terms, I want to see what I can factor out to leave behind a 3x plus 5. And if I factor out a positive 3, that will leave 3x plus 5 left behind. So that means factoring by grouping did work now. So I can take 3x minus 5 out of both of my two big terms. And that will leave a minus 2x and a plus 3 left behind. Okay, so let's do a little bit more work here. This is now more common factoring, essentially, but dealing with fractional exponents or negative exponents. The good news is, and this is if we sort of flash back to what we did before with common factoring, when I did the very first example and we were talking about how we decide what's left behind, Remember that we figured out what was left behind by thinking about division, and in other words, by thinking about subtracting our exponents. The reason why we had 9x left behind from the first term was because when we had x cubed and we factored out x squared, then the power left behind should be 3 minus 2. The power we originally had minus the power that we've factored out. And when we were trying to figure out what was left behind for the y's, we had y to the 4, and we factored y squared out of it. So what was left behind, the power was our original power minus the power that we factored out. So 4 minus 2, or 2. The good news is that this approach doesn't change depending on the kind of numbers we're dealing with. So even if we're dealing with negative numbers or fractional numbers, the idea is still going to be the same, that we'll figure out what's left over essentially by subtraction, and what we factor out is always the smaller power. Smaller or more negative power if we have negative numbers involved. So if I'm looking at this first example here and trying to figure out what have I got left behind after I do some factoring and what can I take out, I'll start off with thinking about the constants. There's 3 and 12. I can factor 3 out of both terms. And then for the x minus 3's, one of them is to the power of 2/3, one of them is to the power of 5/3. I'll be able to take out the smaller of the two powers. So I'll take out the power of 2/3. So from the first term, I factored everything out. I had 3 and I factored out 3. I had x minus 3 to the 2/3 and I factored all that out. So I should only have 1 left behind. If you have something and you factor everybody out, and then there's only 1 left remaining. For the second term, I had a minus 12, and if I factor 3 out, that'll leave a minus 4 behind. And for the x minus 3's, this is where I'll need to do my subtracting. I had x minus 3 to the 5/3, and I'm factoring out, or removing, 2/3. So when I go to figure out what the power is on my x minus 3, it should be 5/3 minus 2/3. And of course, 5/3 minus 2/3 is the same thing as 3/3, and 3/3 is the same thing as 1. So this is the same thing as just really x minus 3 to the 1, which is the same thing as just x minus 3. So I'm almost finished here. The only thing left to do really is just to simplify that last bracket. So I multiply the minus 4 into the bracket to get me minus 4x plus 12. And now I've got a 13 and a minus 4x. And there we go. That's as nicely factored as that's going to get. So for this, I had no negative exponents to worry about. If I have some negative exponents to worry about, of course, I've got to think about that as well. And we'll see an example of that a little bit later on. Let's do some more. Here I've got some y's to various powers. Again, I'm going to take out whatever is the smaller power. So here I've got y to 3/4 and y to 11/4. So if I'm looking at that, I can see that 3/4 is the smaller power, so that's what I'll factor out. And there's no constant that can come out of both terms, so I'll just leave the 16 alone for now. So that means in the first term, 16y to the 3/4, when I take out the y to the 3/4, I'll just have 16 left behind. For the second term, I had y to the 11/4, and I'm factoring out y to the 3/4, so I'm going to subtract 3/4 from that power. And just to do a little bit of cleaning up here, 3/4 when I subtract, or 11/4 when I subtract 3/4 from that, that's 8/4, which is the same thing as 2. So really what I've got for that second bracket is 16 minus y squared. And of course, 16 minus y squared, that is a difference of squares, so I guess I will need to factor that as 4 plus y, 4 minus y. And there we go. Okay, one last one to do here. So this one I've got negative exponents. So reminder that when we're factoring things out, we're factoring out the smaller or more negative power. So if I'm looking at my two big terms that I have here, I have x squared minus 3's that are in common to both. One of them with a power of negative half, one of them with a power of positive half. So what I'm going to factor out is the smaller or more negative of the two powers. And so that would be x squared minus 3 to the negative a half. And so from the first term, that's the easy one. X squared is the only thing left over there. From the second term, that's the one that's going to take a little thinking. I originally had x squared minus 3 to the half, and what I'm removing, or what I factored out, is the power of negative a half. So for my new power, it should be half minus negative a half, which is the same thing as positive 1. So really, what do I have? I've got that x squared minus 3 to the negative a half times x squared minus x squared minus 3 to the 1. Or in other words, minus x squared minus 3. That second bracket, that cleans up pretty quickly for me. I'll have x squared minus x squared, which is now gone, and I'll have minus negative 3, which is positive 3, so that's cleaned up fairly nicely. Here, you might think that we're finished, but we're not quite yet, because here we've got really x squared minus 3 to a negative power. And remember, we don't want to leave negative powers in our answer, so I guess that means rewriting this as 3 over x squared minus 3 to the positive a half. Now, this is where we need to remind ourselves of one further thing. This is still not in simplest terms, because of course, x squared minus 3 to the 1/2 is the same thing as square root of x squared minus 3. Essentially, what we've got is a root in our denominator, and that means that we're not in simplest terms. We need to rationalize our denominator. Now, conveniently enough, because this is just a one-term thing in the denominator, this is the one that's the easier one to rationalize. I just need to multiply top and bottom by that root. So on the top, I'll have 3 times x squared minus 3 to the 1/2. And in the denominator, when I multiply x minus 3 to the half times x minus 3 to the half, I get x squared minus 3 to the half plus a half, which is 1. In other words, I just get x squared minus 3 in my denominator. And now that should be in simplest terms. So we did some factoring, and the factoring led us to more work. So you can see that sometimes you might have a single question that might have a bunch of things to consider, as in the previous example where there was a difference of squares as a surprise at the end of it all, or in this one we have rationalizing our denominator as a surprise at the end.